Okay, so last week, Meta released the CodeLlama model. We knew this was coming. There were quite a lot of rumors about it. What I'm going to do in this video is go through not only just looking at that model, but amazingly, since then, we've had a whole bunch of different fine tunes for that model from the likes of the WizardLM people, a new startup, a number of different groups have done different fine tunes of that. So what I want to do in this video is have a look at the original model and then go in and have a look at some of the fine tunes, which have supposedly made the model a lot better than what it was when it was just the version from Meta. Okay, so what is CodeLlama? This is basically Llama 2, but trained for a lot longer on code-specific tasks. So they've put up a blog post. You will need to re-opt in to get the access to download the CodeLlama models. The models themselves are actually up on Hugging Face and in the Hugging Face format already. So let's jump in and have a look at, what they actually are and what's interesting about them. Okay, so the CodeLllamas are fine-tuned from Llama 2 base models. There are 3 different types of the models. So there's like the base model, the base code, which means it's fine-tuned from the original base Llama 2 model. There's the instruct model, which is trained for doing tasks where you ask it, write me a function that does this and this and this. And then they've got a whole model just dedicated to Python. So they're the 3 types of models that they're releasing. On top of that, they have 3 model sizes that they're releasing. So they've got a 7 billion, 13 billion, and a 34 billion. So it is interesting, the absence of the 70 billion model. So I don't know if that's going to come later or, what the issue is with that. So on the benchmark front, these models are doing really well. So we can see that, the llama-python is doing better than, quite a bit better than GPT 3.5 for this. Still a long way behind GPT 4, but we can see that this model is, trained to do a lot of these kind of tasks. Interestingly, their benchmarks are also showing to be, quite a bit better than some of the other Palm Coder models, some of the GitHub Copilot models, and obviously things like the open source Star Coder models there. So the method that they've used for training this is what we call an infilling objective. So this is a little bit like some of the BERT and T5 models were trained on. Basically what they do is that they have a piece of code, and then they cut out the middle of that, and then they try to get the model to actually predict, okay, what would have gone in the middle there? So they can actually do this with a series of special tokens for having a suffix and a prefix, and then the output would be whatever went in between this. So they call this kind of training, fill in the middle training, or giving it a fill in the middle capability there. So this basically allows you to do a lot of tricks that some of the GitHub Copilot models are doing, where it's looking at your code, it's filling things in. When you ask for a specific function in a particular class, it can see everything that went before and after and works out what is best to fill in there and what variables to use, etc. Okay, so they've put a nice graphic in here so that we can see exactly what they've done, right? So they started with the Llama 2 foundation model. So remember, they've trained on 2 trillion tokens. Then they've done this code training and infilling training for another 500 billion tokens. So that's quite a lot. That's ending up to being a quarter of the original training done again just for sort of code. Then they split it off into 2 different ways of thinking. You can see here on the left here, we've got the Python model. So they do another 100 billion tokens just on Python. I think some of that is also perhaps synthetically generated stuff. And then finally, what they do is they do this long context fine tuning. So once they've got the model working well, they then go on to do this long context fine tuning. So the original model is 4,000 tokens. They train it out to be 16,000 tokens. And then they actually use some positional encoding tricks to make it go beyond the 16,000 tokens for this. But we are actually getting a model that's fine-tuned out to 16,000 tokens, which is pretty cool in this sense. Because as you can see on the left here, they do the Python code training for another 100 billion tokens, and then doing the long context stuff. On the right, they do the long context fine-tuning, but then they split it out to have 5 billion tokens of instruction fine-tuning. Now, it's interesting that just to see As we know from a lot of the llama models, the instruction fine-tuning stuff often ends up being quite small, in relation to the overall training. And this holds true here. We can see that this instruction fine-tuning, remember the instruction fine-tuning would be asking it, please write me a React class that does X, Y, and Z, or, write me a snake game, those kind of things in here. So we can see that is only 5 billion tokens at the end for this. And this is the model that probably most people are going to want to use, the instruction fine-tuning, when you're asking it to write stuff. My guess is that the Python model is made probably to do well on benchmarks because a lot of the benchmarks are aimed at Python. Also, that's what a lot of people are going to end up using as their sort of replacement for GitHub Copilot if you're using Python, etc. The instruction fine-tuning one, though, is a very specific model that people can use to start code bases from scratch to get it to write to things. And my guess is that this one will probably be quite good at PAL, at doing the program-aided language logic stuff. So that's something that we can check out and have a look at ourselves when we go through it. When we look at the actual benchmarks here, we can see that the human eval, which is one of the main ones that people use for checking code models and stuff like that, we can see that the 34 billion llama is coming in better than the GPT 3.5, quite a bit when we look down here, but still a bit off the GPT-4 model, which does make me wonder if they had released the 70 billion, would that be almost on par with GPT-4 for coding? So definitely some interesting questions to be answered there. If we look at the star coder models, they're doing far less than even the smaller 13 billion Python model in here. Okay, so this has been released under the same license that Llama 2 was released under, so you can use it for commercial things. They've got a bit of information in here about responsible use and what they want people to use it for. And they're talking about that they've also developed now a responsible use guide here to actually talk about how people should use this for preparing data, for fine-tuning, for defining the different policies around this and evaluating and improving performance, etc. As with some of the other models, they're not giving any guarantees on this. You should test it and red team it yourself with adversarial prompts, etc. Okay, so let's have a look at some of the fine-tunings of CodeLlama. The first and probably the main fine-tuning I think that's worth looking at is the WizardCoder. So this is from the team that did the WizardLM models. They've also done a Wizard Math model, which was interesting as well. They have published papers about all of those. And what they basically did was take the data set, I'm guessing that they created before, using their llama-instruct method. And if you want to see more about the method that they did with the llama-instruct, you can actually come over and read the paper. I also did a video about this a few months back when we talked about the llama-instruct for the original WizardLM, which was really interesting. And then since then, they've made a much bigger data set using the same methodology. And it seems they've also made a code data set using the same methodology. As far as I know, they haven't released the data set publicly. When I went in and looked at Hugging Face, I couldn't see it. If I'm wrong, please someone point me to a link for this. So they talk a little bit in here, obviously, about their large language models, some of the different approaches that they're using for doing the llama-instruct for code models. But this is by far the one that has done really well, their WizardCoder, 34 billion. And basically, they've used that data set to just fine-tune the Llama 2 code model. And you can see here that they've got this nice diagram in here where they basically benchmark against a variety of different models. Everything from some of the MPT models, through Palm, through Llama 2 models, right up to the GPT-4 model. And one of the things that's really interesting in here too is this whole section about, they point out that the GPT-4 models and the scores that Meta reported on release of the CodeLlama, they actually believe are invalid, that they've run their own evaluations, and their own evaluations shows that OpenAI's current version of GPT-4, which has probably been fine-tuned since the original version, is actually testing much higher than the previous one. Same for the ChatGPT 3.5 model in here. Certainly the interesting thing in here is that the WizardCoder Python model that they fine-tune, 34 billion model, is getting 73% when benchmarked on the human eval data set in here. So they point out that this is better than a lot of models such as Claude, such as a variety of these different things. They also benchmark one of the other ones that we're going to look at is the Phind model in here, which has a bit of controversy about it, which I'll take a look at in a second. One of the things that I do like in here is not only have they benchmarked against these models, they've gone and actually re-benchmarked some of the other models, such as the GPT models, Claude, Bard, etc. in here. And they're basically saying that WizardCoder comes in a bit below the GPT 3.5 and a fair bit below GPT 4 in passing. Another thing that's really interesting in here is that they give you, the code for benchmarking this, so you could go through and benchmark these yourself and see, okay, how the various models are actually performing in here. Okay, so the second fine-tuned model that I wanted to have a look at was by this group called Phind. I think I'm guessing it's Phind here. Okay, they've basically taken the CodeLlama 34B base model as well, and the Python model, and they've trained on an internal data set. I've never heard of this startup before, so I had to come look. It seems like they are a coding sort of assistant startup. They basically claim to be like a pair programmer. So for those of you who don't know, pair programmers is when you have two programmers sit together and write some code together. It can be a really useful way to write code. You often just through talking things out, get a better quality code from two of you talking about how you would do it. And you often spot bugs. Obviously, the challenge is it can be quite expensive. So it seems like they're trying to do this kind of service with AI in mind here. So they basically have trained up a couple of models. And the second one on August 28th is claiming that it can beat GPT-4 on the human eval. Now, this is beating the old GPT-4 scores. As we saw with the WizardCoder, they were claiming that actually GPT-4 now is much better than what it was in the past, and same for ChatGPT 3.5 as well in here. For me, what's more interesting in here is whether this model or the other model is better. I don't know. I personally don't think just one benchmark is the best way to tell something like that. I think you're really going to only work things out like that over using it for, quite a bit of time and getting a sense, is this the right model for you in particular here? I will note that when we come in here and look at the model itself for download, there was a bit of controversy as to whether they used WizardCoder as the base model or used some of the llama-instruct ideas for the data set. I'm not sure. They're claiming in here that they didn't use that. I'll take them at their word here for doing that. But if you're interested, you can just come in here and read a little bit about that controversy. Honestly, I don't think it helps either side to focus on that too much. What I'm more interested in is actually how they did this. So that they claim that they've basically done it on a proprietary data set of 80,000 high quality programming problems and solutions. And they've done that instead of just code completion examples. So again, this kind of shows us that the instruction fine tuning is a big one for the win, right? This is something that we've seen with so many of just the plain language models. And it's turning out to be true for the code language models as well. So they train over 2 epochs here for a total of 160,000 examples. They didn't use LoRa. They've basically done a full fine tuning in here. They've also used flash attention 2, which is kind of interesting to see. And the token sequence that they've gone for is 4,096 in here. Another thing that was interesting, which I think is kind of cool, is that they talk about how they applied OpenAI's decontamination methodology for the data set. Now, first off, I would say OpenAI, personally, I don't think has a great reputation for decontamination, but maybe this is why they've, created a methodology to try and prevent this forward. And here they talk about that, they used that methodology and found no contaminated examples in here. Anyway, this is definitely a model that's worth looking at. You can come in here and try it out. I've tried using the spaces, but I haven't had much luck using the spaces. They seem to be taking a long time for doing this, and I'm not getting good results out of them. But by generating here, I took one of the prompts and the user message that I was using before, basically getting it to write a Python script to download and transcribing YouTube videos. It takes a URL as input. And you can see that it's clearly on track. It only generates a certain number of tokens at a time, and then I have to click it to generate again. But you can see that as we go through, and I'm guessing it's generating maybe 30, 50 tokens or something, or even less here. It is actually looking like it's doing some. Now, one of the things that was interesting as what it produced compared to the Wizard model when I was playing around with this was that the Wizard model went for just a standard Python package, and the Phind one has actually gone for Google Cloud Speech for doing the transcription part. So again, that's kind of interesting. I do wonder that you're limited if you wanted to say get a model that could do this for Whisper. My guess is that most of the data that these people are generating is coming from GPT-4. So the fact that GPT-4 was trained before Whisper, unless it has been fine-tuned with examples like that more recently, you're just not going to get the data to be able to do that for something like a Whisper, a LangChain, or some of these things that have just come along more recently in here. But anyway, this is the Phind model. It's definitely worth checking out. If you're interested in code models, go through, have a look at this. One thing that I would say is a little bit disappointing is that on Hugging Face, I'm not seeing the data sets for either the Phind fine-tuning or the Wizard fine-tuning. So we're left looking for data sets for this. And in that search, while I was looking, one of the things I did find was this. This seems to be a self-made data set from someone called Nick Roche. And it's basically using the llama-instruct code data set, again, for making 80,000 examples. And he or she has basically put together the 80,000 examples here. And one of the things that I thought was really cool was not only did they give you the data set in here, but I think it's he has gone and actually given you the code for how he actually did all of this as well. So I think that's really good to see as an example. If you wanted to make something like this, how would you do it? How would you put it together? And then for trying it out. The last thing I would say to finish up these code evaluations is it does seem that these data sets, some of the magic that is getting this base CodeLlama model to such a high standard that it's being compared favorably with ChatGPT 3.5, GPT-4. And it makes me think now that we can fine-tune ChatGPT 3.5 is what if we were to take that model and tune it on one of these data sets? Would we get a fine-tuned version of GPT, which is much better than perhaps the GPT-4 model that hasn't been fine-tuned for the same kind of thing? So that's something that's maybe worth checking out in the future. Anyway, as always, I'm going to leave it there. I'm going to put some links in the description if you want to find these models, if you want to try them out yourselves. As always, if you've got questions, please put them in the comments below. If you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.